Morning, folks. Looks like a few people are starting to stream in now, which is nice. Get started once a few more people show up. Good morning, folks. Okay. Excuse me. Okay, well, I got 13 people here. Maybe we'll wait for just a few more people to show up. Hello. And you know, I'll go on Discord as well. So if you prefer using Discord, I'll set that up now. I haven't been using it for all my classes because I started using it for all my classes and then just no one was using it. So there you go. Okay, so you want to go on Discord then. Good. Okay, grade 9, grade 9 advanced. And go live. There we go. Okay, so I'm on Discord now. So if you want to join Discord, you're more than welcome to. Okay, we got about 20 people here, so that's good. So yeah, I think we can get started. I'm just gonna do a few examples today, and then we'll call it a day. It's not gonna be a super long class. So yeah, we'll just do a few examples, and it'll be great. Okay, so what is the Discord? You can check the website. The Discord link is on the website. I hesitate to put it on YouTube because I don't like. I've had a few instances in the past where I posted it on YouTube, and then YouTube is very public, and I think that some people outside of our class are actually watching the streams, which is fine. But I don't want to give invite codes on YouTube because I only want the students on. I only want you guys on the Discord. I don't want anyone to be able to join the Discord. So I believe the Discord link is. I think it's on the website. I thought it was. I'll put it on the website right now, just in case you haven't joined it already. So I'll copy this. And I'll put it in the updates section of the website, and I'll do that right now. Insert a little text box, Discord link, and I'll do this. Oopsies. There we go. Okay, so it's on the website, right? Well, it's just publishing now. Okay, it's on the website now. So if you check the updates section of the website, there should be an invite link to the Discord. So yeah, you can use that to join it. Why don't I type it here? I just explained why I don't want to type it here. I don't want it on YouTube because there's some people who aren't in our class who watch YouTube. Yeah. Okay. Okay, so before we get started, I just want to remind everyone that there is a feedback form on the website, so please take some time to fill that out. So there is a feedback. So I want your feedback about online learning and school and final exams and homework and assignment stuff. So take a minute to fill out that form. So yeah, on that form I ask several questions. It shouldn't take too long. It should take less than 5 minutes to fill out the form. Don't do it right this minute, please. We'll actually have class in just a minute. But I would like you to spend just a few minutes to give me some feedback about how things are going. I'm really curious about how this is working out for you. I mean, usually in class I can see your face, which is a really good indicator of how things are going. You'd be surprised. Like, I can usually tell if students understand it by looking at their face, because sometimes they look confused, sometimes you're nodding, that kind of thing. So in a similar way, I don't really know how you're doing in terms of like your well-being, if there's anything that I can do to make things go easier, or more engaging or more interesting. Also, I ask a little bit about final exams, what you'd like to do about that. So yeah, take a minute to fill it out. It's really hard to miss. It's right on the home page. So if you just go to our website, then you can't miss it. It's just right on the front page to click that feedback. So yeah, please give me some feedback. I'd love to hear from you about how your classes are going, in particular this class. It'll really help me plan for that final term. Okay, so yeah, and look at that. See, after all that, no one is on Discord. So I mean, I'll keep it online. Are we gonna learn anything new today? Well, it depends. Depends on if using the elimination method is new to you or not. That's what we're going to be learning about today, is the elimination method, and we're going to do a few word problems, and then that'll be it. So it should be a fairly short class, not too much content. So you did learn elimination. That's fantastic. So this will be a review for you then. So yeah, at this point of the stage, we've covered pretty much all of the course content, and at this point I'd like to start doing some review, and if we still have time after that, I mean, we still have a full term. So I mean, I really do like to do reviews and kind of cycle back and kind of revisit old topics, because I think people often get the impression that once you learn something in math that you're just finished with it, right? And you're not just finished with it. You have to keep using it because it'll come back. And furthermore, all of these math topics, they're very intertwined, and sometimes it's hard to see that when you first learn something, how it's related to something else that you're learning. But all of this is intertwined, so if you kind of have forgotten about a specific method on how to solve something, then you're not going to do yourself any favors, because when you learn something new, you may have to use that old topic. So I think it's a good idea to sort of revisit some old topics. And if we're finished all that, then I might start kind of just throwing some more content at you, some stuff that's outside of the grade 9 advanced curriculum. But we'll see. I think it's still a good idea to kind of do some review and make sure that we remember how to do all this stuff. So we're going to talk about the elimination method. Oops, that's too thick. Here we go. The elimination method. Okay, so the elimination method is based on a fairly straightforward principle. that so keep in mind that if let's say that if x is equal to y, let's say that these two things are equal. Actually, I'm going to use different letters because I think that we often think of x and y as being very specific variables. So this applies to anything. So if a is equal to b, then I can have and I'm actually gonna put the then over here. Then x minus a is equal to x minus b. Like I can subtract, right? Because x is equal to x, right? X is equal to x. So if I subtract a from it, since a is the same thing as b, then if I subtract a from x, then that's the same thing as subtracting b from x, right? I mean, like if let's say that, for example, a was equal to 7. That means b is equal to 7. Therefore, x minus 7, well, that's obviously equal to x minus 7. And that's really what the elimination method is based on, is this principle that if a is equal to b, then x minus a is equal to x minus b. Just saying, if two things are equal, then you can subtract something, or you can subtract both of them from something else that's equal, and you haven't changed anything. So, for example, let's do a straightforward example. Let's say we have this system of equations, and I'm gonna just quickly change this one. Okay, so let's say we've got oh, and also this also I could have this as plus as well. I could add it, I could subtract it, I could even multiply it, and that would be okay as well. So yeah, what I'll do is I'll write plus or minus. Plus or minus means that you can either add or subtract, and if you have two of these symbols, as long as they both have a plus on top of the minus, then that means that you do the same operation both times. So x plus a is equal to x plus b, and x minus a is equal to x minus b. Okay, so we're gonna use that little fact to solve a few things. And again, I apologize if this is a review and that you're already an expert at it, but I still think it's a good idea to revisit it. Can you divide it? Yes, you can most of the time. When do you think you couldn't divide it? I'll let you think of that. When would you not be able to divide both sides by a and b at the same time? So yeah, we'll say that x. Why don't I make a list? You can have x plus a equals x plus b. We could have x minus a, which is equal to x minus b. We could have x times a, and that's going to be equal to x times b. But if we have x over a equals to x over b, I'm going to put a little star there, and yeah, I think that in the chat it's kind of become evident. Yeah, this happens so long as a is non-zero, and that's a nice little shortcut because if a is not zero, that means b is also not zero. I'd only have to specify one. Okay, does x plus a equal to x minus b? No, absolutely not. Unless a and b are both equal to 0. But yeah, x plus a is not equal. X plus a is not equal to x minus b. No, it has to be the same operation. It has to be the same operation. Does x, okay, and b over a 0? I'm not sure what that means, but yeah, no, I think that's a really good question. Can you divide both of them by a and b? Well, yes, as long as a and b are non-zero. And I should also point out that like if x is equal to y in this case, then now it doesn't have to be x on both sides. We could have x minus a equals y minus b, right? If x is equal to y and a is equal to b, then we can have all sorts of different kind of equations that come out of it. Anyways, we're kind of digressing here, which is great. It's really good to think about these things. But let's get to an actual problem, and we'll talk about why this works. So I'm gonna do this one here. So I'm gonna solve this system using elimination. Okay, and elimination here, this means we're going to get rid of one of the variables. We're going to get rid of one of the variables. It's going to be great. Okay. So we're going to solve this system using elimination. Okay, great. So what is the system? Let's write it out. I've got negative 5x plus 3y, and that's equal to negative 18. And I've got negative x minus 3y equals negative 18. Okay. So elimination. Okay. So here's how this works. So what I'm going to try to do is I'm going to look for terms that are really similar here, and in particular I'm looking for terms that are that have a variable in them, because I want to eliminate them. So what I'm looking for, I'm looking for terms that are similar. Okay, I'm looking for terms that are similar that have a variable. So I can eliminate it. Eliminate them. Okay, so I'm looking for terms that are similar. Okay, and what I mean is two terms that are in each different equation. So the one that I see is the plus 3y and the minus 3y. And the way that I would go about sort of deleting this term, or either of these terms, is to add them together. Okay, I'm going to add them together. So we can sort of think of sort of like this first one as being like this thing right here is A, this sort of thing over here is being B, and this sort of thing over here being X, and this thing over here being Y. So I know that A is equal to B, right? I've got the left-hand side of that top equation is A, and the right-hand side of the top equation is B, and X is equal to Y here, and you know, I actually should not be using X and Y here. That is what we call an abuse of notation. So let's say C and D. So I know that C is equal to D. Okay, so the left-hand side of the bottom equation is equal to the right-hand side of the bottom equation, which means that I could add both of these things together. I can add the left side, so I would have A plus C is equal to B plus D. And this isn't typically the way you would solve this if you were just doing it. You wouldn't have to name A, B, C, and D. I'm just trying to illustrate what we're doing. So this A, B, C, D stuff is purely for your learning. It's and your understanding. It's not what we actually do as a procedure. I'm just saying this is why this works. Okay? So if I've got A and B are equal and C and D are equal, then A plus C is equal to B plus D. That's what we're doing. So I'm going to add these things together. So I can erase this now because we're sort of done with that. So I'm going to add all this stuff together. So I'm going to add the left-hand sides of the equation together and the right-hand sides. And the reason I want to add them is because I know that plus 3y plus negative 3y is equal to 0. And if I did that, then I would eliminate the y value, and then I would have an equation with just x, right? The whole problem with these equations is that there's two variables, right? You can't solve for two variables at the same time if you only have one equation, right? So if you have two variables, there's like an infinite number of solutions. So if you can eliminate one of those variables, then you can solve for that one lone variable. So let's go ahead and do that. So I'm going to add these together. So the way we can do that is just like in grade 3 where you add numbers together. I'm going to do this. I'm going to add them up. And so I've got negative 18 plus negative 18, which is negative 36. And that's equal to, well, positive 3y plus negative 3y. Well, that's 0. That's the whole point. That's the whole reason we're adding them, is so that we get a 0 somewhere. We want to get rid of one of those variables, and we just did. And I've got negative 5x plus negative x, which is negative 6x. So our new equation is negative 6x equals negative 36. And we can solve for this. So divide both sides by divide by negative 6. And it turns out x is equal to positive 6. And that works. So x is equal to positive 6. Okay? So now what we can do is we can choose either one of the equations, either the top one or the bottom one. So now we can choose one equation. It doesn't matter which one. That's the whole point of this, is that these equations have equal priority. We're trying to satisfy both of them at the same time. So we'll choose one equation and plug in x equals 6, then solve for y. Okay, so I'm going to do that. I've got negative 5x plus 3y equals negative 18. I'm going to plug in x equals 6. So I've got negative 5 times 6 plus 3y equals negative 18. Kind of running out of room here. I've got, so that's negative 30 plus 3y equals negative 18. Okay, now I'll add 30 to both sides, which gives me 3y is equal to 12. And that means that, well, I'll divide both sides by 3, and that gives me y is equal to 4. Okay, so this solution is, so the solution is x equals, what was it, 6, and y equals 4. Or the way I would actually prefer that you write it, which is kind of a little more compact, is to write 6 comma 4, right? Because that's how we would describe the point of intersection. So what I'd like to do now is just open Desmos real quick, and I'm going to graph both of these. So I've got negative 5x, negative 5x plus 3y. That's the first one, plus 3y equals, what was it? Negative 18. Negative 18. That was the first equation. The second equation that we had was, what was it? Negative x minus 3y. Negative x minus 3y equals, what was it? Equals negative 18 as well. Negative 18. Okay, so that was the other one that we had. And would you look at that? The point of intersection is 6 comma 4. So that's exactly what we got. So it's really important to understand that all of these things are intertwined. It doesn't matter which method you choose, you're going to get the same solution. So going back to here, I just want to interpret the solution one more time. Okay, let's take a look at the original system. So here's the system of linear equations. I'm just going to copy them and paste it down here. Okay, so the whole point of this solution, what this solution means is that in both of these equations, so in both of these equations, if x equals 6, then y equals 4. So these are the only, this is the only pair of points, x and y, that these two equations can agree on, okay? So let's just double check. So negative 5 times 6 plus 3 times 4, let's see if that's equal to negative 18. Well, negative 30, well, let's just double check. I've got negative 30 plus 12, is that equal to negative 18? Yes, it is. I've got negative 18 equals negative 18. Give myself a check mark. And then, oops, negative x minus 3, oops, I'm supposed to be plugging these in. Negative 6 minus 3 times 4, is that equal to negative 18? Well, let's try. So I've got negative 6 minus 12, is that equal to negative 18? Yes, it is. Negative 18 is equal to negative 18. Check. So that's what this means, is that this is the only point that these two equations can agree on. And we solved it using elimination. So both of these equations are equal, so I can subtract one from the other. Or in fact, what we did this time is we added one to the other. So I'm going to do one more example. This time it'll be a bit of a harder example. It won't be quite as straightforward, but hopefully you'll see the method that I'm choosing. So let's see here. I'm trying to find a good one. Yeah, let's do. Here's a good one. Here's a good one. I'm just kind of looking at a list of questions here. Okay, so here's, I'll do this one here. So we're going to solve using elimination. By the way, if you're just asked to solve a system of equations and there's the method that you solve it is not specified, choose any method you want. But if it asks you to use elimination, you'd better use elimination. Or if it asks you using any other method like graphing or what have you, then use that method. You have to use that method. Okay, so let's go ahead and do this. Okay, what was it? Okay, negative 9x, negative 9x plus 16 equals negative 4y. Negative 4y. And the other equation was negative 27x, or sorry, negative 27, hold on a sec. What method did we use for semester? Like the powers, but it was for solving equations. Rules of powers. Oh yeah, I could talk about that maybe another time. Hold on a second. This is actually not a very good question. Yeah, that's fine. You know what? Actually, this is not a good question. I want to do another one. Sorry about this, guys. Here's a much better question. I thought this question was good, but it wasn't. This one is much better. Okay, we're gonna do x plus 3y. X plus 3y is equal to 15. X plus 3y is equal to negative 15. Negative 15 and negative 2x plus 6y is equal to 6. Okay. Okay, no, not powers. I feel like it was elimination. Rules of powers. Yeah, there's only so many methods for this that you'd learn in grade 9 or in grade 10. There's far more advanced methods for solving these. Like you can imagine, like let's just, so before we attack this problem, I'm just kind of seeing in the chat that people are talking about different methods for solving these. So I mean, just think about where this is going. Like, basically, since grade 7 or maybe grade 6, depending on who your teacher was, you've been able to solve equations, and this has nothing to do with what we're just talking about. So for a long time, you've been able to solve equations that have, well, it's just one equation and one variable, right? And then after that, you start graphing them. So you graph. You start graph. It's one equation, two variables, and because it's a line, there's an infinite number of points on that line. So there's an infinite number of, like, quote-unquote solutions, because it's an infinite line. Those are all the values that work for that equation. And then now what we're doing is we're solving one equation, or sorry, two equations rather, two equations and two variables, right? You can kind of see a pattern here. So sort of ignoring the graph, maybe I didn't have to talk about graphing. It's not super relevant. I mean, it is, but so for a while you've been solving one equation with one variable. Now we're doing two equations with two variables. You can imagine that you could solve n equations in n variables, where n is equal to like 2, 3, 4, 5, or some big number, right? There's very interesting methods that you can use to solve huge systems of equations. That method that you'll eventually learn one day is called something, using something called a matrix. So you can use a matrix to solve these huge systems of equations, and it's actually really fun. I really enjoy working with matrices. So a matrix looks something like this. Basically, the way it works is you actually use elimination. The method of elimination is what you end up using, but what you'll find is that eventually you don't really care about the x and the y's and maybe z or w or all the variables that you'll use. The only thing that really matters here is the coefficients, right? The coefficients in front of the variables, right? Everything else, the x and the y's, those are just going to be the same. So what you end up doing is you write a matrix with all the coefficients in here. So you'd have like A, B, C, D, E, F, G, H, I, right? And then you've got this matrix, and it's like this little square with these numbers. And then what you end up doing is you perform operations on the rows, and you switch rows upside down and stuff. And really all you're doing is this elimination method. And this is something that you'll eventually do. Like if you end up going to university and you take a class called linear algebra, that's what this class is all about, is it's solving systems of equations. And that's what we're doing right now. We're just kind of doing it in kind of a more controlled environment where it's fairly straightforward questions with a straightforward answer. But you'll be able to eventually, using the same method, you'll be able to solve huge systems with like as many variables as you want and as many equations as you want, and you'll be able to solve them with a very high degree of accuracy. So it's a lot of fun. Anyways, I'm digressing because I'm getting excited because I love linear algebra so much. It's a very fun class. I used to teach it in university back when I taught at the U of W. Okay, so what were we doing? What was that? And this was a 6. Okay, I just want to make this look a little bit cleaner. There we go. So we're going to solve this one. So we're going to use elimination. And you might be saying, well, hold on a second. How can you eliminate any of the variables? None of them are the same. None of them are the same. How can you eliminate these if none of them are the same? Well, the trick is that you just make them the same. Right? Just like you'd be solving an equation, right? Like maybe sometimes in an equation you have to multiply both sides of the equation by a number. Well, let's do that. So let's see if one of these is a multiple of the other. And it turns out that there's two sort of directions we could go. We could try to eliminate the x, right? We could try to eliminate the x's. The other option would be to eliminate the y's, and it doesn't matter. You could do either, and either would get you this exact same solution. So there is some flexibility here. I am going to eliminate the y's. I think that it's going to be more revealing, or it might make a little more sense to eliminate the y's. So let's get rid of the y's. And the way we're going to do that is I'm going to say, okay, look, this 3 goes into 6, right? So this 3 right here goes into this 6 exactly 2 times, right? So how about I manipulate this equation? So I'm going to manipulate this, right? Because you can still manipulate these equations in any way that you want, as long as you're following the laws of algebra, which are basically what you do to one side, you do to the other side. So as long as we do the same thing to both sides of the equation, we're good. So let's go ahead and do that. I'm going to multiply both sides of the equation by 2. So I'm going to do times 2 times 2. So I've got, so this first equation, I'm going to call this equation equation 1 and this equation 2. So equation 1 now becomes, well, I've got 2x plus 6y equals negative 30. Right? And equation 2 now becomes, well, negative 2x plus 6y is equal to 12. Oops, not 16, 12. Okay, so that looks good. And you can probably see that now there's a lot of things that we could do to get rid of one of the variables. So you'll notice that I could either, like if I added these two equations together, then that would eliminate the x's. But if I subtracted the two equations, then that would get rid of the y's. So so there's a lot of possibilities now. Why is it 12? Oh yeah, good question. It's not 12. It's still 6. We didn't manipulate the second equation. My bad. Good catch. It's 6. Yeah, we didn't actually touch the second equation. The second equation we left alone. So what I want to do is I said I was going to get rid of the second equation. So what I'm going to do is I'm going to subtract this equation from the other one. Okay? So basically what I'm going to do is I'm going to write this minus sign outside of this. So I'm essentially subtracting the second equation from the first equation. So let's go ahead and do that. So I'm going to have 2x minus negative 2x. That's the same thing as 2x plus 2x, which is 4x. Now I've got 6y, and I'm just going to sort of put a pointer on where I'm thinking about. So I've got 6y minus 6y, which is 0, right? Then I've got negative 30 minus 6, which is minus 36. So our equation is 4x equals minus 36, right? So we've narrowed it down to just one variable, one equation, one variable. So now I can divide both sides by 4, and I get x is equal to negative 9. Okay, so I'm halfway finished now. So x is equal to negative 9. That much I know. And now I can choose either of these equations. It doesn't matter. I could choose 1, I could choose 2, or I could even, if I wanted to, I could use the manipulated one as well. It doesn't really matter. I can use any of these. The whole point is that these equations are supposed to be consistent with one another. So I know that they're going to be consistent with one another when x is equal to negative 9. Now we just have to figure out what y is equal to. And I'm just for the fun of it, I'm going to use equation 2. Why not? So equation 2 is negative 2x plus 6y is equal to 6. And I know that x is equal to negative 9. So I've got negative 2 times negative 9 plus 6y is equal to 6. Now I just say that well, negative 2 times negative 9 is positive 18. We have positive 18 plus 6y is equal to 6. Subtract 18 from both sides. I get 6y is equal to negative 12, or y is equal to negative 2. So when x is equal to negative 9, y is equal to negative 2. And just to be sure, I'm going to graph these in Desmos, and then we'll see what that looks like. So this first one was x equals, you know what, I've actually got it on my computer, so I can just punch it in. So what was it? Negative, wait, which one? Oh yeah, it was x plus 3y. X plus 3y equals, x plus 3y equals negative 15. And this one here was negative 2x, negative 2x plus 6y plus 6y equals 6, And there we have it. And their point of intersection is negative 9, negative 2, which is exactly what we got. So you can see that this graphing method is consistent with our solution using the elimination method. So the elimination method, the substitution method, the graphing method, they'll all get you the same solution. Typically, I find that the graphing method is not the most reliable because it's only as good as your diagram. So sometimes it can be inaccurate, or maybe you may be tempted to like round to the nearest whole number. In any case, yeah. So what we can do now is I can just get you to finish the rest of that assignment, or not assignment, but the homework on the website, and please fill out the feedback form on the website. So please do those two things. So you can finish, the homework that I assigned on Tuesday, and you can also complete the feedback form on the website. So please do those two things. And it looks like we ended up using the full 45 minutes. Anyways, I thought maybe we would go under today, but looks like we spent the whole time. And look at that, we only did 2 examples. But I did a lot of talking. So anyway, I'm gonna sign out now, and I'll see you guys on Monday. So next week we're gonna do Monday, Wednesday, Friday, because we're sticking to even school days. So yeah, so next week we'll do Monday, Wednesday, and Friday. So take care, guys, and I'll talk to you on Monday, and have a good weekend. Bye bye.